All right, class.
Yes.
Woo! All right, you're 10 times better than my class yesterday. All right, so this is my third hour.
Yes.
Yeah, you got. Oh, okay. Anyway, all right, so we got 20. What is it? 26, 27 today? 25, 26? 26, 27. So this one's going to be 26, and this one right here is going to be 27. All right, so these are our practice side, and then we're going to take a look at this right here. So for this first thing right here, if you notice, I don't know if you guys were able to actually play with these when you were in elementary school or, preschool, the number blocks to show you guys like place values. So this right here is a 10 by 10.
Yeah.
So 10 by 10. So that means how many's in this one?
100.
Okay, that's 100. How many of those do we have?
3.
So that is a 300, isn't there?
Yeah.
Okay. So again, then we have number blocks, and these ones represent tens, don't they?
Mm-hmm.
So it's going to be, how many's here? 20, right? So there's 20 together, and then each one of these are individual. So let's see, we get, how many we get here? 9?
5 and 4.
Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9. So it's going to be 300 plus 20 plus 9. Or we could also say in dollar bills, we have 3 hundreds, 2 tens, 9 singles. Right? Okay. Or, now, here's another way of writing it with exponential notation. So 10 to the second power, 10 squared is 100, right? Because it's 10 times 10. Okay, so 10 times 10, so 3 times 100, that's 300. And then 2 times 10 to the first, so 10 to the first is going to give me 10, so times 2 is 20, right? And then anything to the 0 power is? 1, very good. So 9 times 1? 9, there we go. So it's just a bunch of different ways of representing the same numbers, just different ways of representing it. So just different things. All right, so now let's take a look. It says consider the polynomial function p given by p of x. So this is 5x cubed plus 6x squared plus 4x. Evaluate the function at x equals negative 5. Okay, so a couple ways of doing this. So it means that I'm going to plug in negative 5 for the x value. So it's going to be, let's see, I'll do it down here. So it's 5 parentheses, negative 5, close, third power, plus 6, negative 5, squared, plus 4 times negative 5. And as you guys plug it into the calculator, there was a big issue yesterday when we're doing the graphing and stuff. A lot of people did not use the right signs, the correct signs for negatives. Because a negative, I'm going to bring up my calculator again here. Okay, so the negative, so if I'm doing this, it's going to be 5, parentheses, the negative is right here. So if you guys are watching my keystrokes on my calculator, it comes up in red, so that's the negative sign. 5, close. Then to do my exponent, it's going to be this caret button right here, little arrow pointing up. There's going to be 3, because I know everyone's trying to plug it in right now, because this is very, very beneficial that you guys learn how to use the calculators, because they're your friends, not food. All right, close, negative 5 again, close, and now this one's squared, because I know you guys are plugging these in, right?
Mm-hmm.
So everyone is trying to play along with us at home, right? Yes.
Yeah.
So yes. All right, and plus 4, open there, and I have negative 5 again. There we go. Yes.
How do you get rid of this?
Okay, press the scratch pad again. You find it? Okay. And if you guys see something in your calculator that you don't like, you don't want to mess with it, you just want to clear it out, all you have to do is hit dock, which is right here, and then you hit the letter B, because if I go all the way down here, B means clear scratch pad. So doc letter B will actually clear everything so you can start with a new. All right, we hit enter, we come up with negative 495. So in my box, I'm going to put in negative. So f of negative, no, it's P, I'm sorry. I'm so used to F. P of negative 5 is negative 495.
495.
There we go. So P of negative 5 is negative 495. And that's the way to write it. All right, so now the next one we're going to do is positive 15. And I'm going to show you a neat trick with the calculator too. So for the next one, it's going to be, so it's 5 times 15 cubed plus 6 times 15 squared plus 4 times 15. So in your calculator, I know everyone's actually doing it right now, right?
Yes.
Everyone is doing it, right? Everybody in the class is getting calculated. And not to throw anyone under the bus, you know, I could actually look at your calculator to see what you're doing. So I'm hoping you guys actually are plugging in a calculator. So, anyone particular? All right, is anyone struggling with how to plug this in the calculator? Anyone need help with the calculator? All right, so let's see then. So right here, if you do this, here's another way of doing this. I arrowed up twice and I highlighted this. I hit enter and it copies it. And I could just change my values. So I'm going to start way over here. And I'm going to delete and make that 15. Delete and make it 15. And delete and make it 15. There you go. So the calculator got rid of the parentheses, even though it is implied that the parentheses is there. $18,285. Is that what everyone got, or we're still working on it?
Yes.
Yes. Yosbeth, you left off the 6 off your middle 15. All right, so let's go ahead and, so I'm going to write it out. P of 15 is 18,285. There we go. Now, how does knowing that 5,000 plus 600 plus 40 equals 5640 help you solve the equation? Equals this. Think about it. Go ahead. What you got?
It's because the first one, it's multiplying by 1,000, and it's cubed, so 10 times 10 equals 100, and then times 10 is 1,000.
Yes, so that should be like
5 times 1,000 is 5.
like 10 to the third, right?
Yeah.
Okay, so you're saying that we have 5 times 10 to the third, right? Plus
6 times
times 10.
10 squared.
All right, because those are my hundreds, right? Plus,
4 times 10.
all right, and then my last one's going to be, because that's going to be a first, right? And it's going to be plus 0 times 10 to the 0. So if you notice, I didn't really need this piece right here, but I'm adding it just for the sake so you guys can see. It goes 3, 2, 1, 0. And for my last units placeholder, I just put in a 0 because my last digit is a 0. So if this digit right here, where's it? This 0 was a 1, this would change, right? So it'd be 1 times 10 to the 0. Okay, good. So it's the exact same thing that we did earlier, right? So for this next part, it says Han, I wonder if his last name is Solo, realizes 11 squared is 121. Okay, and then we have x plus 1 squared is equal to this trinomial here. Then 11 to the third is going to be here, which expands like this. The digits in the power of 11 correspond with coefficients of the polynomials. Okay, so digits in the polynomials right here. So there's a 1 in front of that x, right? Yes? Okay, so that's what it's referring to. And then when I square it or cube it, this is my term. So it's going to be a 1, a 3, and a 1. Okay. So is it still true for 11 to the 4th? Okay. You got a calculator, right? What is 11 to the 4th?
42,641.
Okay, so now if I expanded that, let's say, so we're saying it's supposed to come out to x plus 1 to the 4th, which should give me x to the 4 plus 4x third plus 6x squared plus 4x to the first plus 1. Okay. It's supposed to be that. And let's see. Since I have this one right here, I'm going to do a distribution once. So I have this, but I'm going to distribute to try and verify x plus 1. Because this is already to the third, right? Say yes.
Yes.
This is to the third, and to get to the 4th, I would just have to distribute one more, right?
Yes.
Very good. So that's what I'm going to do here. So I'm going to show you guys my work on this. Okay, so let's see if it works out. So I'm gonna actually do the distribution, but I'm going to put my numbers down here. So this is going to be x to the 4th plus 3x cubed plus 3x squared plus 1x. Now I'm going to distribute my second number right here. So 1 times x cubed is 1x cubed. So now I'm going to line it up like this. This is another way of actually doing this. So as you're distributing big numbers like this, so binomials, you could do it easily with back and forth. But for bigger than that, if you line them up going like this with your powers, it helps out a lot. So the next one's going to be 3x squared plus 3x squared plus 3x and then plus 1. So what I did right here, it's a stacking method to be able to multiply polynomials. So I'm going to go ahead, I don't have anything to add it with, so I get 1 plus, combine those together, I got 1 there, 3 there, so it's 4x plus together I get 6x squared plus 4x cubed and plus x to the fourth. Is that what I came up with here? All right, does that work? Yes, it is. Okay, so now it says I could actually get another one here, right? Let's try this one right here. Now, I think I'm gonna jump straight to it. There's a pattern to this, and I'm gonna show you guys the pattern. So I'm gonna go to the back right here, so I have enough room. So I have 1, 2, 1. That was my first one, right? That was 11 squared. The next one is going to be 1, 3, 3, 1. Okay. The next one was what? 1, 4, 6, 4. All right, so now if I'm doing this correctly, I can find my pencil. That's a problem with having, oh, there it is. So if I did this correctly, I get 1 all the way here, right? So my first term is always going to be 1, isn't it? So yes. All right, so, and then the next term is going to look like this. 1 plus 2 is? 2 plus 1 is? Okay, how about this? 1 plus 3 is? 3 plus 3 is? 3 plus 1 is? Okay, let's see if we could figure it out using the same pattern, getting the next one. So so my first number is going to be 1. My next one's going to be? What's my next one? Next one? 10. Very good, right? Because you guys are doing this, right? So it's going to be, so here's my 10. Here's my 10. What's my next one? 5. And then? So this one would be the same as saying, since we said this one right here, this is the second, the third, the fourth, the fifth. This is going to give me x plus 1 to the fifth power. Kind of neat? No, it's not neat. Oh.
I put it on my calculator, that's not it.
So 11 to the fifth power?
Yeah, it's 161.51.
161.51?
161,051.
So does it work for the fifth? No. So, but up until a certain point it does, but it also gives us the pattern that we were looking for. So we had, watch this, we had this x plus 1, right? And my last polynomial was x to the, what was this, fourth? Yeah. Plus 4x cubed plus 6x squared plus 4x plus 1, right? That was the last one, wasn't it? That was the last one that we did that we know worked out. So we did work it out. So let's go ahead and I'm going to do my distribution again, but I'm going to stack them. So as I keep going, so it's going to give me x to the fifth, and then it's plus 4x to the fourth, plus 6x cubed, plus 4x squared, plus x. And now I'm going to stack it, so I'm going to distribute this. So it's going to give me x to the fourth, plus 4x cubed, plus 6x squared, plus 4x plus 1, 5x, 10x squared, 10x cubed, 5x fourth, x to the fifth. Does that match what we have here? So this is actually a way of doing this when we're expanding binomials to a point where, you know, you're going to have huge numbers. If I wanted to actually keep doing this over and over and over again, an exponential, so some large, super large number, I got to try my best to come up with a way to not have to keep doing this over and over again. So let's go back to this. So mathematical justification for this. Yes, it did work here, but 11 to the 5th power was what?
161,000.
Okay, let's. I'm gonna find my calculator.
1610.
Yeah, 11 caret 5. So it doesn't work out, does it? So 161051. Nope, doesn't work, does it? But it does work all the way up to the 4th. That was very helpful, wasn't it? So that was just trying to get us to that point for the pattern. Okay, so now let's talk about this one here. Oh crap, my mouse is there somewhere. All right, so now we're working on this next one over here. So we're looking at this pattern. So for this pattern right here, it says, okay, a yearly gift. At the end of 12th grade, Claire's aunt started investing money for her use after graduating from college 4 years later. First deposit was $300. If R is the annual interest rate of the account, and then at the end of each school year, the balance in the account is multiplied by a factor of X equals 1 plus R. After 1 year, the total value is going to be 300X. So after 2 years, it's going to be 300 times X times X. After, write an expression for the total value after graduation in terms of X. All right, so now for this, it's going to be how many years? 4, right? Because if the first one is here, right? The second one is here, right? So it's going to be 300, and it's going to be X to the 4th, like that. But then X is the same as this, isn't it? 1 plus R, whatever my rate is. So that's going to give me 300 times 1 plus R to the 4th power. So I can keep doing this. If Claire's aunt had invested another 500 at the end of her freshman year, what would the expression be for the total value after graduation in terms of X? So let's look. So for this, I would start off with invested 500, right? So 500. What would be the expression at the end of her freshman year? So freshman year, high school. What would it be? So if she invested it earlier, it would be like this, right? 500 times 500 X to the end of her freshman year. Oh crap, sorry. Another one here. I missed that part right here. Sorry. End of her freshman year. So I was thinking at high school, but it's actually not. So this is going to be another 500. So it's going to be this one, the first one, which is 300. X to the 4th, right? But then another 500 is going to go where? So it's going to be 300 at the first. Oh, crap. You know what? I'm running out of paper already because I keep making mistakes. So it's going to be 300 X at the end of her first freshman year, right? 300X plus 500, right? And so the next one after that, it's going to be what? Okay, so it's going to be times another X, right? So it's going to look like this. So it's going to go 300 times another X, isn't it? So this is going to be the second year. So when I distribute, it's going to be multiplied here, and it's going to multiply by here. Okay, so that's the second year. This is second year. Okay, so this was freshman year. So this is the second year. So after 2 years, third year is going to look like what? 300 x plus 500. And then this is going to be x squared, right? Because I'm still compounding another year there. So that's their junior year. And so the last one would be, oh crap, I lost 300. Man, why is my x plus 500 x cubed? So now it's going to compound that much faster because as I keep expanding this, it's going to keep getting more. So if I add another investment at the end of each year, it would keep getting bigger and bigger. On just that piece is going to compound more. So this one right here was going to compound the most, right? This is going to compound 4 times. Yes, times the rate 4 times. This one is going to compound the rate, say 3 times. 3 times. And if I would have invested again after the junior year, yeah, so it would just keep going like that. So as my investment keeps going, if I keep investing more and more initially at the beginning, and then they will compound whatever the rate is that I'm going to get out of this. Does that make sense or no? So if I were to do this, it's going to be 300 x to the 4th, kind of like that was my initial that kept getting invested, right, from the beginning. And the next one plus 500 x to the 3rd, right? That's only going to be invested after the first year. And so from there, it's just going to keep compounding. So if I kept doing more and more at the end of each one, that's going to be what we're going to have. So it's going to be better to invest more here because it's going to compound quicker. This is actually a super good idea for you people because there is a very, very funny video. I don't know if you guys watch the show Futurama. Yeah, maybe, kind of. Bender is great. Okay, all hail Bender. All right, so where Fry, he has $1.38 in his checking account. $1.38. That's nothing, right? That's almost nothing. So he takes his $1.38 and he leaves it alone in his checking account at an average interest rate of 3%. And it comes out to be in the trillions because he was frozen for 1,000 years. So I'll even show you the math on it. So compounding it sooner helps out a lot to get it more. So $1.38 times 1 plus my rate, which is going to be 3%. So that's going to be 0.03 compounded annually for 1,000 years that he was frozen. So big it goes into scientific notation. So there's 12 zeros behind this. 3 zeros is 1,000. 6 zeros is 1,000,000. 9 zeros is a billion. After million goes billion. And then 12 zeros is trillion. So basically $9.48 trillion. Yeah. So that's what your student loan's going to look like. Anyway, all right. Just joking. All right. It's really not going to be that bad. All right, so let's take a look. So for this part right here, it says, suppose 250 was invested at the end of sophomore year, 400 at the end of junior, an additional, okay, 300 and the 500 at the end of the freshman year. So 200, 250 end of sophomore year. So it's going to be right here. I would have my 300 x, right? And it's at the end of the sophomore year. Oh, crap. Sorry. Thank you. Speak up, man. Yeah, all those people in YouTube land, that one person that watched this video, thank you. All right. So if it's after after the freshman year, right? So freshman year is going to be this, and then it's going to be plus 500, and then this is after the freshman year. Then sophomore year is going to be a multiplier there, so it's going to be 300x squared, right? Plus 500x, and now on this case, I'm adding right here. How much am I adding? 250. So right here, and then it's going to be an x. And then the next one, so it's going to end up coming down. Let me zoom out a little bit because I'm cramping my space right here. So it's going to end up being 300x to the third plus 500x squared plus 250x. So,
Say it like that.
to what? What? Say what like what?
250.
Yeah, 250.
Don't say it like that.
See? Everyone else. An additional 300 junior year, right? So the next one's going to be
300x.
and what was it? 300? There we go. 300 right there and my 250. So that's after junior year, right? And then my last one, oh, that one is it. And so, yeah, so it's really not going to help out if you invest something at the end of the senior year. So we come out to be something like this right here. At the end of the junior year, that's what you get. And if you compound all that your senior year, it's going to get x to the fourth, x to the cubed, x squared, and then x. So, and at your senior year, you're just handing them cash. That's not going to invest at all. All right, so now, okay, we don't really have time for this last one here. So, it's a calculator problem anyway. So, do you guys understand? Kinda? Yeah, we're going to go make some money. Don't forget, like, share, and subscribe. And salsa on what day?
Tuesday.
Tuesday, my dudes. All right. All right, so someone's bringing chips.